Hi, I'm Oscar.
Hi, I'm Max.
Hi, Max.
Hi.
Welcome to Beta Talks.
Great to be here.
You have something nice for us?
I have something nice for us. I have test containers.
Test containers.
Yeah.
Okay. So we're talking about testing, which is very important.
Which, of course, it's really important. And I'm going to take you through the test containers. So what does it do?
Mm-hmm.
How can we employ it in a .NET project? And how does it work?
How does it work? Well, that's interesting. But first off, why do we need it? I would say. Well, testing is important. We have unit test, end-to-end integration, whatever. Where is this?
So I mean, of course, we like as developers, we enjoy making functionality for our customers. But our customers then also expect from us that the functionality that we deliver works as expected, right? And for that we have tests. So, previously in the faraway history, we started with manual testing, right? You know the books, going through one by one and testing each time, taking months. Gladly, right now we have some more automated tests. And test containers really helps us with that. So that's quite fun. So we have unit tests. I think that's the most known testing.
That's where your automation starts normally. Like it's a developer saying, well, I built this and it should stay working like this. These are the constraints.
Exactly.
And like unit tests are also a form where you can do TDD with to say, well, I'm first speccing it out and then doing an implementation. But this is a bit wider. This is addressing a problem that we will have with an integration test, right?
Exactly. So the nice part about it, unit tests, is they work in isolation. But we see that as soon as we move to integration tests, or classically at least, we use a single application and we fire at it. We keep firing at it. And the problem is, especially if you introduce some parallelized unit tests or parallelized tests, that they interfere with one another.
Oh, we have two things.
Right?
We have stuff working in parallel, which interferes with each other or needs to create isolated cases. Sometimes you can work around this with building your app in a certain way. But we also the issue with begin state of a test. Like you want an empty begin state for a special situation and then test it and then go away and start again, right?
Exactly.
That's the key in test containers, isolation.
It is isolation indeed. So test containers employs Docker, and with that we can spin up a new container with our REST API, with our front end, with our database, and run that in isolation for each separate unit test. So then we can make sure that each unit test is not influenced by others, or is not influenced by other.
Like now we're talking about test containers, but are we isolating the test or are we isolating the environment? Because I can imagine having a complex environment with a database and some storage and a disk and whatever, then you need to build it. And I have seen implementations of versions of applications. You spin out a whole part of a cloud, but this is not doing infrastructure as service and run a temporary environment. But this is doing all that with use of Docker containers.
Indeed. So we try to capture our architecture within Docker containers and then spin that up for a single unit test, then bring it down again, and then for the next one, bring it up.
Sounds somehow like really overkill. Like build your complete instance in memory of your database, spin everything up, and then throw it away and do the next one, or even do the next one without throwing it away because we have isolation.
So you could name it overkill, right?
But basically, if it performs, that is the dream, right?
Well, that's the dream, and I mean that's also the dream of Docker, right? Have lean images, spin them up, bring them down. I mean that's the promise. Especially also combining this with cloud, I could imagine that you have some resources to rely upon. Well, and that in combination, I think still makes us for a performant set of unit tests or integration tests. Right?
Okay, but like maybe I'm a developer, but show me the code. Like, how do you implement this?
I waited for this moment. So right here we have a nice ASP.NET Core application. So I just created a standard CRUD-based. We have a user controller we can create a new user. We can get them by ID. We can get them all. Okay,
so our baseline here for this example is a REST API, and we're building test against the REST API?
Yeah, exactly.
And its state? Is that in memory or is that more?
So this runs with a SQL database behind. So for this instance, I just run the Microsoft SQL local database.
Yeah, okay.
Well, of course, you can think of many things to use in production. I wouldn't use a local database, for example. And then we then dive deeper into the code, right? Because that's what we want to see. That's where the money is. Well, this is one of our integration tests already, and you might notice, okay, we're using XUnit.
Yeah, I see fact there.
Yeah, and it looks quite similar to a unit test, right? So we have some setup that has to be done. So we create a container, and with that, in the second step, we run
Yeah, from line 16, I see you're building a HTTP client, so you're gonna ask something from the API, expect something back, and that's your test in this case.
Exactly.
But the line 15, for me, that's interesting,
Line
because
15
that's spinning up this test container, this environment. What does it do?
Indeed. So that's a separate file that I've created, and what we really do there is the steps in order to indeed spin up that environment, spin up the Docker environment. So the thing that we start with is, in order for us to spin up a Docker container from our application, we first need to build a Docker image.
Okay, so your API has a Docker file with it to build the API.
Yeah, indeed.
Basically. Okay.
So I just created this through the Visual Studio interface. What it does is it restores the package, it builds it, and then it publishes it.
But it ends up with a container image that you would normally publish to your test environment.
Exactly.
Okay.
Exactly. So and there we see the entry point as well. And if we then, well, so on lines 34 until 38, we can then see, okay, this is where we create that image, and it invokes Docker with the Docker file, well, internally, in order to create that Docker image.
So this is basically orchestration to interact with your Docker desktop in this case, to spin up certain containers. So basically your app that you just built, but also dependent resources.
Also dependent resources, indeed. So what Testcontainer does, and it does it quite nicely, is apart from, well, our custom containers that we can, or our custom images that we can create, it also provides us already with some out-of-the-box functionality. So this SQL Edge Builder, for example, is already provided by Testcontainers, and it provides some functionality for us to create a SQL, a Microsoft, I think, Azure Edge SQL server.
Yeah, really simple, lightweight, like your local almost, just
yeah, exactly, and it's really nice because for your standard dependencies, they already have they already have something implemented, so we can build that with little code. And then, well, on lines 48 till 55, we can then see, okay, with that image, we build our own API container, so the one that we in the end will be talking against.
So this is actually the image that you see the Docker file for. It's going in the last one, right? You're building there your app.
Exactly.
You're connecting it to the SQL container that you defined, and I see some network setup.
Indeed. So
you're creating a whole environment there with running containers, hooking them up together.
Exactly.
And then your test suite, because you have an XUnit test that runs. That runs from Visual Studio, or does that also pack it in a container?
No, so the test suite itself actually runs from Visual Studio still, so on the host machine. So really, what we can see if we scroll a bit more to the bottom as well. So here we have a method which constructs a URI, because the API container is exposed to the host container as well on a random port.
So you get a port, and that's your entry point on your local machine, so local machine port, your entry port for your test to, well, the HTTP client that we just saw to connect with that one.
Exactly. So that's really neat. And then, well, the tests really are as simple as just using that method that we just looked at, and then running it.
It's simple, and I can imagine a real environment, a real test is a bit more complicated. But you can abstract a lot of stuff away.
Exactly.
I'm thinking a scenario. Where are our problems? Like normally a database, to get them in a starting state for your test. You're either starting from scratch, throwing, I don't know, maybe a duckpack in there or a backpack, or inserting a lot of stuff and then starting with your test. If you have a lot of baseline to start with, you can you create a specific image? Yeah, why not?
Exactly. Well, so we just saw how to build the image for our application. Of course, we can also make a custom image for our database, which already has an initial data feed.
So if you for a lot of master data and stuff, and it's like, well, this is the snapshot of where we start.
Exactly, and although one of those containers might contain some information or some configuration, like we can see here, we can encapsulate it quite nicely in a single class. Yeah, and then just run it through code, through normal .NET code.
And
I find it so impressive.
In this case, XUnit, so the standard behavior is to run all these things in parallel.
Yep.
The limiting factor is compute. Memory.
Compute, indeed. So I think that's also where cloud ties in quite nicely, right? If we have some opportunity to use this in the cloud, then we can run in parallel with the compute that we have there. We don't really need to rely on local.
Basically, it's a test runner. It's a unit test runner, so we can do that in a normal test agent. Any test agent where we can also spin up Docker containers.
Indeed,
it's just
that's the only requirement.
So in the background, while running this, you would see containers spinning up of those images that you built in parallel and going down again.
Indeed,
breaking. And
indeed,
it's just real compute.
Yeah. So what it really does is it creates an image. And then using that image, it just spins it up and down.
So in this case, it's an API test, but I can fully imagine anything you run in there now, like fully integration end to end, which needs isolation because it has some overhead, right? It's setting the environment up.
Indeed,
it's not super light. If you can do chain tests on a similar starting point, fine.
Yeah.
But this was the one that was hardest to build, right?
Yeah, I find so.
Clean start.
Exactly, and of course, I mean, integration tests have their own place in the whole testing pyramid, right? We don't have to rely on that from every little piece of functionality, but really the purpose that it does serve, well, that's where I think this really simplifies things. It simplifies things quite a lot.
I think Docker entered the testing world, and it will be a first-class citizen there. This is definitely the future of integration testing.
I definitely think so too.
Awesome. Yeah, we will definitely dive into later. Maybe we can do that together too, because I saw the Azure App Container jobs, which is an excellent replacement to do build agent with, which gives us basically unlimited scale and gives us the opportunity to define a lot of memory. Yeah. So I'm really curious, like even a big test set, and like in how many seconds we can get feedback after a check-in.
Yeah, that really sounds promising, right?
That this is very interesting. Well, we made a video, so let's anyone who might be interested in this, or we can point out that they have a problem and that this solves it, even though they don't know it themselves.
Exactly.
Our testers are getting some emails shortly, and this is awesome. Thanks. I didn't see it yet. It looks great. Your first session, but
first session indeed. Happy to be here.
Yeah, it's gonna be hard to top that in your second one.
Well, I'll try my best.
Thank you so much.
No problem.
You so much for watching.
Thanks for watching.
We'll see you next time.
Bye.